The Physics of Interstellar Travel. Chapter 1. Introduction. Welcome to the Physics of Interstellar Travel. I'm Corinne Byler-Jones. This set of videos asks what is the physics behind getting an uncrewed spacecraft to the nearest stars within a human lifetime. We will address questions such as what propulsion technologies are available, how fast could a spacecraft move, what will it encounter along the way, how can it navigate autonomously? What science would it do? And how can it send back data over the vast interstellar distances? These short lectures serve as an introduction to my book, The Physics of Interstellar Travel, published by Cambridge University Press. The book is both available in printed form to buy and is published under an open access Creative Commons license, so it is also free to download. The book is aimed primarily at those who have completed introductory university courses in physics, but parts of it are accessible to readers less comfortable with the mathematical aspects. A lot of articles and a few books have been written about specific aspects of interstellar travel. Some of these are rather technical or assume a high level of background knowledge, so it can be hard to connect to the basic physics. My approach in the book is to start from basic physical concepts, and by taking a broad view, I aim to give the reader a sense of the big picture and understanding of the physical principles at work. I cover a wide range of topics and draw extensively on recent literature, so the book should also be useful for researchers. The book is organised into 17 chapters, and while they could be read in any order, there is some logic behind the ordering. The main dependencies between the chapters are summarised in this diagram. After giving some motivations for interstellar travel, I cover rockets and orbits before discussing some essential results in special relativity. After describing various types of nuclear rockets, we look at solar sails and laser sails, as well as magnetic and electric sails. We then examine the vast space we must cross, the interstellar medium. From here, we proceed to methods of navigating in deep space, how to communicate over light years of distance, and finally we consider the payloads and instruments we would want to equip our spacecraft with. I finish up in chapter 17 with an outlook and a brief discussion of some of the broader issues. Chapters 2, 16 and 17 contain no maths, as do several sections in several of the other chapters. In both the book and these videos, we will look at some fairly extreme applications of physics, such as gigawatt lasers and fusion engines. But I only consider ideas based on existing, proven physics. I don't cover things like faster-than-light travel or wormholes. On the other hand, we will look at solutions that involve some extreme technology that do not yet exist, or that appear absurdly expensive or difficult, but which are nonetheless plausible. I also limit the scope to sending robotic, uncrewed spacecraft. Human interstellar spaceflight is a fascinating topic, but involves much beyond physics, such as the biology and psychology of crews. Sending robotic spacecraft that can survive the journey will be hard enough without having to consider the problem of squishy organisms that can plane and die easily. There is one video lecture for each of the book chapters. These videos provide just an introduction, a taster, to each chapter. I leave out many things and take shortcuts, so you'll need to check the book for details. But you can find a brief summary of each chapter in the book's introduction. To go further, you'll need to delve into the specialist literature, and at the end of the book I give some suggestions for further reading. Before we get going, let's put our journey into some perspective. In some strict sense, we've already achieved interstellar travel. 5 spacecraft have escaped the gravity of the Sun and are already leaving the solar system. But even the fastest of these, Voyager 1, is moving at only 17 kilometers per second and will take 77,000 years to cover the distance to our nearest star, Proxima Centauri, although it's not going in that direction, and it will be defunct long before it gets anywhere near that far. If we shrunk the distance of Proxima Centauri to be once around the Earth, a distance of 40,000 kilometers, then the Earth-Sun distance is a mere 150 meters. As of 2026, Voyager 1 is still only 25 kilometers from the Sun on this scale, not even 0.1% of our way to our nearest star. So our main challenge is to achieve fast interstellar travel. If we want to get to Proxima Centauri within 50 years, the spacecraft needs to move at 25,000 kilometers per second, nearly 10% the speed of light. But speed isn't the only issue. The spacecraft must also survive the hazards of the interstellar medium, navigate to the right place, and be able to transmit data back across the vast distance it has travelled. These are just some of the issues that we explore in the book and in the next 16 videos.